In this problem, we're told to suppose the lengths of pregnancies of a certain animal are approximately normally distributed with a population mean of 244 days and the population standard deviation of 13 days. And we have several parts here to complete below. So one of the things that we'll use in this problem is StatCrunch. So we're going to rely on some technology to help us find the probabilities that we're asked for. So this first one is asking us to find what's the probability of a randomly selected pregnancy lasting less than 239 days. So we'll come over here to StatCrunch, select Stat, Calculators, and Normal, because remember this was an approximately normal distribution. We'll then update it with the mean and standard deviation for the population. And we wanted to find the probability that the pregnancy lasted less than 239 days. We'll click compute and we see a visual diagram here of that region shaded under the normal curve, as well as the requested probability. In the next part of this problem, we're asked to then interpret this probability. And notice that of each of these, we're being told if 100 pregnant individuals, ... So what we want to do with the probability is multiply 0.3503 times 100, and that gives us approximately 35. And so then we just need to make sure that we're matching up the correct statement, the remaining part of that statement. And again, that original probability was that the pregnancy lasted less than 239 days, over here less than. So we want to make sure we're selecting part C and filling that in, that answer space in with 35. For the rest of this problem, what we're doing is taking a random sample from this normally distributed population of data. So in part B, we're told to suppose that a random sample of 19 pregnancies is obtained. And then we're asked to describe some things about the sampling distribution of the sample means. So what I want to do, first of all, is bring up some information from our textbook. And this information comes from section 8.1 of our e-text. And so the big ideas that we need to take away here that we're going to be using is that the sampling distribution of X bar has a mean, this sampling mean, that's equal to the population mean. That's pretty simple. The standard deviation, however, to get the standard deviation of the sampling distribution, we need to take the standard deviation of the population and divide that by the square root of the sample size that was drawn from that population. So that's something to keep in mind. We will need this little formula here. So to describe the sampling distribution of X bar, we will first say that that's normal with a sample mean that is equal to the population mean. So we'll just keep that as 244. But the standard deviation of the sampling distribution, we'll need to take the standard deviation, which was 13, and divide that by the square root of the sample size, which in this case is 19. So we'll just bring up a calculator and do that really quick. So I've just Googled calculator, and I'm typing in 13 divided by the square root of 19. And that's how we arrive at this standard deviation for the sampling distribution. Now that we have this value, I'm going to copy that and paste it into my normal calculator inside of StatCrunch. Because in this next part, we're asked what's the probability a random sample of 19 pregnancies has a mean gestation period of 239 days or less. Notice how the only thing I really needed to change here was the standard deviation. It is something different compared to the population standard deviation, but it is based off of that with that little formula. Everything else I'm keeping the same, and then when I click compute, I find that probability I was looking for. I could copy and paste that into here. And then next, when we're asked to interpret that probability, we want to take this value, multiply it by 100, again, because I see 100 in each of my answer choices, and then make sure that the rest of the statement matches up with what I just found. That, like in this case, if 100 independent random samples of size 19 pregnancies were obtained from the population, we would expect 5, and that comes from this times 100, 5 samples to have a sample mean of 239 days or less. That was what we had calculated over here in our normal calculator. So moving on to part D, you can see what's changed here is that the sample size is now something different, 39. So I'm going to keep the same mean, but I'm going to calculate a new standard deviation with that formula from the e-text that says it is the standard deviation of the population divided by the square root of the sample size. In this case, it's 39. So I would want to grab that value. I guess I'm going to go a little bit further here and then just round when I come back to my normal calculator. Round that last digit up to follow my rounding rules, and then click compute. And here it is. And if I round that to the 4th digit behind the decimal, I get this same probability here. And then again, just like the other problems, I'd want to take that value, multiply it by 100 in order to finish answering this next part about interpreting the probability. So rounded to the nearest whole number, 0.0082 times 100 would be 1. So I would expect one sample to have a sample mean of 239 days or less. Again, given all the other setup there is the same. In part E, we're asked to interpret the results of that probability yet again. When we're asked here, what might you conclude if a random sample of 39 pregnancies resulted in a mean gestation period of 239 days or less? Remember, that only happened out of every 100, according to what we had calculated before. So that's very unusual. We would say this result would be unusual, so the sample likely came from a population whose mean gestation period is less than 244 days. Okay, so next we're asked what's the probability of a random sample of size 19, or that a random sample of size 19 will have a mean gestation period within 8 days of the mean. So we need to go back and recalculate that standard deviation that we had before, and update that here in our normal calculator, as well as change some other things. So let me first grab that value for the sample size of 19. Okay, so I've redone that here and I've pasted it here. Next, I want to change my calculator to between because I need to find the probability that this sample has this gestation period within 8 days of the mean. So that means 8 days less than 244 and 8 days more than 244. And then compute, grab that value and paste it in here, rounding that last digit up.